Hey guys, welcome to InterviewBlog. In this video, we'll be covering the question smallest difference. So the question gives us two arrays and it wants us to determine one number from each array such that the difference between the selected numbers should be minimum. So let me explain the question to you. So in this example, we are given two arrays and we need to select one number from each array. So from the first array, I'll be selecting the number 10. And from the second array, I'll be selecting the number 9, such that the difference between these two numbers is minimum, that is 1. So my straightforward solution or my naive solution to solve this problem would be finding all the pairs of numbers that are possible using the given input array and finding their smallest absolute difference. So let us consider a simple input 2, 1, 3, and 4. So in this case, I'll be generating all the pairs that are possible. That is, this 2 will be paired with 3 and 4, and this 1 will be paired with 3 and 4. So all the pairs are 2, 3, 2, 4, 1, 3, and 1, 4. So the absolute difference between 2 and 3 would be 1, and the absolute difference between 4 and 2 would be 2. The absolute difference between 1 and 3 is 2, and the absolute difference between 1 and 4 is 3. And the minimum of these differences is 1. Hence, I'll be returning this 1 as my answer. So as you can see, the time complexity of this solution tends to be big O of n into m, where n is the length of the first input array and m is the length of the second input array. So why is it n cross m? It is because we are generating all the pairs of numbers that are actually possible using the given two input arrays. The space complexity of this solution can be big O of 1 if we do not store these combinations, or if we prefer to store these combinations, our space complexity will also be big O of n cross m. So can we do better? Let us now consider the same input, but in this case, you can see that the given input arrays are in sorted fashion. So there is an advantage when the given input array is sorted. We can simply traverse the given input arrays simply once to find the smallest difference. So what I mean is, first, I will be comparing the first element of the first array, which is 1, and the first element of the second array, which is 3. While comparing 1 and 3, we can find that the absolute difference between 1 and 3 is going to be 2. So after finding my absolute difference, there arises a question about which pointer we have to move forward. Now, the question is whether to move this pointer or to move this pointer. So to find that, we'll be comparing the numbers 1 and 3. So while comparing 1 and 3, we can see that 1 is less than 3. Now, since the number 1 is less than 3, I'll be moving this pointer to the next position. So what I'm doing here is I'm moving the pointer which points to the smallest element. This is because when we move this pointer to here, we can see that our new combination would be 1 and 4. And the absolute difference of this 1 and 4 would be 3, which is greater than 2. And our objective is to find the smallest difference. Hence, there will be no requirement to try this combination of 1, 4. So that is why I am incrementing the pointer from the smaller element. So this is how our solution is going to be like. So if you cannot understand the problem, don't worry, we'll be seeing the problem in detail now. So initially we are going to have two variables, that is our smallest difference and current difference, which is set to infinity. So our next step will be sorting both of the given input arrays. So after sorting the first array, we get 2, 4, 5, and 10. After sorting the second array, we get -1, 7, 9, and 13. So we are going to use two pointers. Our pink pointer is going to traverse the first array, and our yellow pointer is going to traverse the second array. So let us now see how our algorithm works. So to begin with, we will be comparing the elements that are pointed by our pink pointer and our yellow pointer. So the elements are going to be 2 and -1. First, what we'll do is we'll be calculating the absolute difference between these two numbers. So the absolute difference between these two numbers would be 3. So we'll be updating our current difference from infinity to 3. So the next thing is we have to decide whether to move this pink pointer or this yellow pointer. So let us say we have two numbers x and y, where x is from the first array and y is from the second array. While comparing x and y, if x is greater than y, we need to move the pointer that is pointing to the second array. And if x is less than y, in this case, we have to move the pointer that is pointing to the first array. So why do we do this? So we will be discussing this part in a while. For now, let us say we are comparing the elements 2 and -1. Since -1 is less than 2, we will be incrementing the yellow pointer, that is the pointer that is pointing to the second array. So our yellow pointer will now point to the element 7. So after incrementing the pointer, we need to update our smallest difference if our current difference is less than our smallest difference. And since infinity is greater than 3, that is our current difference 3 is less than our smallest difference. Hence, we'll be updating our smallest difference from infinity to 3. So now again, we are going to repeat the steps. So we'll be calculating the absolute difference between the elements pointed by the pink and yellow pointer, that is 2 and 7. So in this case, our absolute difference is 5. So in this step, our current difference is 5. And now we need to decide whether to move the pink pointer or our yellow pointer. For this, we'll be comparing the elements 2 and 7. So while comparing 2 and 7, we can see that 2 is less than 7. Hence, we need to increment this pink pointer from 2 to 4. So now let's say instead of moving this pink pointer from 2 to 4, we move this yellow pointer from 7 to 9. So what will happen? So I am moving my pink pointer back to 2 and I am incrementing the yellow pointer from 7 to 9. So in this case, we'll be finding the absolute difference between 2 and 9 and it ends up to be 7. In parallel, let's say that I move my pink pointer to the next position and our yellow pointer stays at the same position. So in this case, I'll be calculating the absolute difference between 4 and 7, which tends to be 3. Please note that this step doesn't make any sense because the absolute difference that is calculated here is greater than the current difference, which is 5. So there is no point in calculating an absolute difference, which is greater than the current difference. So all we need to find is the smallest difference, and hence moving the pointer which points to the smaller element is the right way to calculate our smallest difference. So hope you are clear. Let me just quickly start over. So now we will be comparing 2 and 7. Since 2 is less than 7, we have to increment the pink pointer from the first position to the second position. So after incrementing the pointer, we will be comparing our current difference, which is 5, with the smallest difference, which is 3. Since 3 is less than 5, we do not update the smallest difference. So now we will be calculating the absolute difference between the numbers 4 and 7. And in this case, our absolute difference is 3. That is, our current difference is 3. So our next step is to find which pointer to move forward. So we will be comparing 4 and 7. Since 4 is less than 7, we will be moving the pink pointer forwards. So after moving the pointers, we will be comparing the current difference, which is 3, with the smallest difference, which is 3. Since both of them are equal, we do not want to update our smallest difference. So next, we will be comparing the elements 5 and 7. So while finding the absolute difference between 5 and 7, our current difference tends to be 2. So our next step is to find whether to move this pink pointer or our yellow pointer. So for that, we'll be comparing 5 with 7. And since 5 is less than 7, we will be incrementing the pink pointer from 5 to 10. So our next step is to compare our current difference, which is 2, with the smallest difference, which is 3. We can see that 2 is less than 3. Hence, we'll be updating our smallest difference from 3 to 2. So now, again, we will be comparing our absolute difference between 10 and 7. So now our absolute difference between 10 and 7 is 3, and our current difference is now 3. So next we'll be comparing the element 10 with 7. Since 7 is less than 10, we will be incrementing the yellow pointer from 7 to 9. So next we'll be comparing our current difference, which is 3, with our smallest difference, which is 2. Since 2 is less than 3, we do not want to update our smallest difference. So next we will be calculating our absolute difference between the elements 10 and 9. And the current difference tends to be 1. So now we will be comparing the elements 10 and 9. Since 10 is greater than 9, it means that we need to increment our yellow pointer from 9 to 13. So now we'll be comparing our current difference, which is 1, to the smallest difference, which is 2. Since 1 is less than 2, we will be updating our smallest difference from 2 to 1. So next we'll be calculating the absolute difference between the elements 10 and 13. And the absolute difference tends to be 3. Hence our current difference tends to be 3. So now we'll be comparing 10 and 13, and we can find that 10 is less than 13. Hence we'll be incrementing our pink pointer to the next position. Now, since we are out of the array, that is, we have traversed the entire first array, our traversal is now complete. So now we'll be comparing our current difference, which is 3, with the smallest difference, which is 1. And we can see that 1 is less than 3. Hence, we do not want to update our smallest difference, and our smallest difference tends to be 1. Now, we can see that we have completely traversed both of the arrays, and hence we need to now return the smallest difference, which in this case is 1. So we'll be returning 1 as our answer. So hope you understood the algorithm. Let us now analyze the complexity of our solution. So the time complexity of our solution tends to be big O of n log n plus m log m, where n is the length of the first array and m is the length of the second array. So why is it n log n plus m log m? It is because we are initially sorting the given input arrays. Hence, our time complexity tends to be n log n plus m log m. Our space complexity tends to be constant. This is because we are not using any auxiliary data structure. We are simply using pointers to traverse the sorted arrays, and hence our space complexity tends to be big O of 1. So hope you understood how the algorithm works. So before moving on to the implementation part, let me quickly make 2 more points here. So we have seen that our time complexity tends to be big O of n log n plus m log m. So this is because we are sorting the given input arrays to solve our problem. But what if the interviewer says that the given input arrays are already in sorted fashion? So in this case, we will be given these 2 arrays as our input, and our time complexity would be big O of n plus m, where n is the length of this first array and m is the length of this second array. So there is no requirement to sort the given input array, as the given input array is already in sorted fashion. So our time complexity improves from this to this. So the next point that I want to make here is the maximum smallest difference that is possible is always going to be 0. This is because at each and every step, we are calculating the absolute difference, and hence negative values are omitted, and the maximum smallest difference that is possible is always going to be 0. So let us now discuss a test case where the first array contains elements 2, 1, and the second array contains elements 3, 1. So in this case, our first step is to sort the given arrays. So we will be having 1, 2 in our first array and 1, 3 in our second array. So initially, our pointers are going to point to the first elements of the given input arrays. So now we will be calculating the absolute difference between the numbers 1 and 1. And hence our current difference is going to be 0. As discussed earlier, the maximum possible smallest difference is always going to be 0. Hence, in this case, since we have already found the maximum smallest difference that is possible, our solution will return 0 as our answer. That is, our current difference will be returned, and there is no requirement to traverse the rest of the given input arrays. So hope you understood the algorithm. Let us now implement it in code. All right. So we got our smallest difference function defined, which takes in two arrays. So our first step to solve the problem is to sort the given two arrays. So I'll be saying array1 dot sort and array2 dot sort. So both of the arrays are now sorted. So next we are going to have two pointers I and j, which is going to point to the first element in the given arrays. So I comma j equal to 0 comma 0. Next we are going to initialize two variables, that is our current difference and our smallest difference, to float of infinity. So now we are going to traverse the given arrays. So I'm going to say while I is less than len of array1 and j less than len of array2. So in this case, I'll be calculating the current difference as the absolute difference between the element pointed by the ith pointer minus the element pointed by the jth pointer. So as discussed earlier, if our current difference is 0, in this case, 0 is the maximum possible smallest difference, and hence we will be returning 0 as our answer. So after finding our current difference, we need to decide whether to move the ith pointer forward or our jth pointer forward. So for that, we are going to do simple comparisons. That is, if array1 of I is less than array2 of j, so in this case, we will be moving our ith pointer forward. Else if the element at the ith pointer is greater than the element at the jth pointer, in this case, we will be moving the pointer which points to the second array. So j plus equals 1. So after updating our pointers, our next step is to update our smallest difference. So I'll be saying smallest difference is equal to minimum of our current difference and smallest difference. So once our traversal is completed, we need to return the smallest difference as our answer. So hope you understood the solution. So this solution has a time complexity of big O of n log n plus m log m, where n is the length of the first array and m is the length of the second array. And the space complexity of our solution tends to be big O of 1. So hope you understood the solution. Let us now test our solution. So this is Lintcode problem number 387, which is the smallest difference. This is the same problem that we discussed right now. So we are just going to paste our solution here. So I'll be saying return. So let me quickly change our function name from smallest difference to smallest difference 1, since both of these function names are same. So I'll be saying return smallest difference 1 of a comma b. So let us now run our solution. So our solution got accepted. Let us now submit our solution. So all the test cases has been passed. Hope you understood the problem. Do subscribe and check out our channel for more videos. Thank you so much.